You are screen sharing. Noise.
A graph.
Yeah, we're not graphing. I was just messing around with that, and I'm using that a lot in algebra. So I was really psyched that I don't know if you guys knew this. You can open an image file in Microsoft Paint and ask it to invert the colors, and the blacks and whites switch places. Probably not that exciting for you. Yeah, you should write this down. Yeah, I'm recording, so woohoo, let's get this show on the road. This won't take too long. Today is 11:20. And I guess what I understand, it's not like it took me a long time to figure this out, but usually with the quadratic formula, it takes not long to teach people how to put the numbers in place of the letters. You know, A, B, and C go in the little spots. But what happens is we figure out, we being us math people as teachers, is that you guys can get through the first couple of steps. And then it's when you get to the end that the trouble starts. So all we're going to practice today is a worksheet that is not using the quadratic formula. It is not x squared plus 3x. There are no x's to be found anywhere. All you're going to get today is a worksheet that has problems that look like this. I hardly ever anymore answer any questions about the stuff that leads up to this point. Everyone understands like the -6 was the opposite of b, and then we did some b squared minus 4ac and got 40, and I don't know. You get the idea. It's always when we get to here that the trouble starts. And so that's why I decided let's just do an entire worksheet of this. Good? Okay, so let's practice. I've got 8 practice problems in the queue. Each one of them, in my hope, is serving a slightly different purpose than the others, but let's see how quick we can motor through these. And with only 5 students here, you guys will have to chip in and speak, okay? So, so I've made it this far. What do I do?
You're going to find out the root of 40.
Good job. So remember, your priority at this point in time is always to take the square root out and go work with it. Always that is the next step. And so at this point, you're going to take the square root of 40 and you're going to break it up into 2 numbers that multiply to make 40. And what numbers in this case specifically are we talking about? 4 and 10 is the only good answer there, because there's others. There's 2 times 20, trash. 8 and 5, trash. But good job, Haley. 4 and 10 is the best combination because 4 is on the red list like this.
So it'll translate into -6 plus or minus the root of square root 4.
Well, what happens is this 4, I wrote him in red because he's a jailbreak. And when 4 breaks out of jail, he square roots himself. He becomes a 2. So what we actually have now is 2 root 10. Follow? Mm-hmm. Everybody up to speed with that? And then the 2 roots of 10 come back and take their place where the square root of 40 used to be. This is what you're practicing today. And then most of the time, there's going to be, you'll remember the Dorito, right? And so the Dorito does not come into play until someone breaks out of jail. But since 4 busted out and became a 2, this green guacamole colored Dorito is now in play. And what do we do inside the Dorito? In this case, half it, right? Sometimes it would be divide everything by 4 or whatever the situation is. This case specifically, all the numbers in the Dorito can be divided by 2. So what's going to happen is -6 is going to become -3. 2 is going to become 1, and 10 is going to become 5, right? One of those numbers does not need to be in my final answer, right? You know which one it is. So when I write this down, I'm going to write it as -3 plus or minus just the root of 10 all over 5. That is what you're doing today, is just practicing the ending. Now, I'm not going to have you do 7 more exactly like this, but that was our first. Any questions about that? Okay, let's go again. Round 2. 2 plus or minus the square root of 12 all over 2. So again, your job is to take the square root out. All right, Just get it out and go work on it someplace else. Like you're hauling it to a different area of the workshop so that you can do something with it, and then you'll put it back in the machine once you fixed it. So what is the square root of 12 when I break it down? Say it again. Perfect. 4 and 3. And remember that we stay away from 2 and 6 because they're not red listable. They're not rootable. So here we go again. You see 4, he's going to be a jailbreak. When he breaks, what does he become?
No.
Good. So then 2 root 3 says, okay, you can plug me back in there now because I'm the fixed up version of root 12. The Dorito is in play. It wouldn't. So I wanted to write this problem into today's lesson just to make sure that you understand that there are 3 numbers in the Dorito. If you get ones, 2 of the 3 do not need to be replaced with ones. One of them, however, does, and it's the one that I'm going to circle in red. This one is what we call a placeholder, and a placeholder cannot just be vanquished because it holds a spot for us. And so when I divide all the numbers in the guacamole Dorito by 2, I get 1, 1, and 1. However, the only one that should stay alive is the one in the upper left-hand corner. So the final answer in this case would just be 1 plus or minus the square root of 3. Done. End of conversation. The one that's in front of the root serves no purpose. So why put it? And then the one on the bottom is something that only weird people do. Like who puts answers over 1, right? Yeah. Only like aliens and people like that. So I guess they're not people if they're aliens. They're smart extraterrestrials. Next one. While I pour myself almost 3 in the afternoon cup of coffee, you guys can work with that square root. What are you doing with the square root of 81? Nope. Say it again. Closer to what I want to hear. It's just 9. Good. Mr. Roscoe's been, this ain't our first rodeo. Remember, when you guys get a square root, a number that is on the red list, there's no need to break it down. There's no need to do that conversation about like jailbreaks and stuff. If you look at your red list right now, you guys all know for a fact that this is true. The square root of 81 just equals 9, right? So having said that, I can get rid of the square root of 81, and in his stead, I can just put a regular 9. Not a root 9, just a 9. And having done this, you remember maybe the name that I gave these types of problems. Do you by chance? These are pathway problems, right? And so the reason I call them that is because now, because there's no roots left, you're expected to go all the way. You're expected to say, okay, I can proceed because all the like terms now are telling me add us together. So my first pathway I'm circling is called plus. This is not an option. This is what you do. So now when you trace the top, the plus pathway, what is -4 plus 9?
5.
It is 5. And then if you take that 5 and you put it over 3, one of your answers is 5/3. That's it. Now, I have to reset and take the yellow pathway. And the yellow pathway is just a different selection in the Choose Your Own Adventure series. Like I just picked a different thing to do. What is -4 down under -9 this time? It is. So then I take my -13 and I place it over 3. And then I put a box around these and I move on to the next problem. Your answers are going to look like this when you get a pathway problem because you get what are called rational solutions as opposed to irrational. So far, so good. Okay, I'm going to step up the difficulty a little bit here. We're going to have to work together on this one. You've seen this square root before. It's just a matter of like, I mean, really, who in their right mind would expect you to memorize every one you ever see? 192 is not on the red list, but he contains something times something where one of the somethings is a big red list number. Nope. That's the one. Nice job. And the more of these you practice, you almost just start to accumulate like a database. Like you just leave them laying around and it's like spare parts in an auto garage or something. So I'm going to take the square root of 192 and I'm going to pull it out here and I'm going to work with it and I'm going to rewrite it as the square root of two numbers multiplied together. And in case you didn't hear what Aubrey said, she said 64 times 3. That is the best way to break down the number 192. There are other ways, but none of them will be as efficient and to the ending as this one. This is the best, correct, perfect one. What is the square root of 64? When he jailbreaks out, what does this guy become? It does. So overall now, this root, the root of 192, is actually finally simplified to 8 root 3. And again, I'm going to grab it and I'm going to reinsert it where 192 used to be. And once you simplify your root, then it's time to do the Dorito. And what can all the Dorito numbers be divided by? They can all be divided by 8. Listen, quite frankly, they could all be divided by 2, but then you'd have to go again. Yes, they could all be divided by 4, but then you'd have to go again. When it comes to reducing things like fractions, you really should always think, let's do this as quick as we can. So if I divide all the Dorito numbers by 8, this 8 becomes a 1. This 8 becomes a 1. And what is 16 divided by 8? I see 2 ones up on top. How many of them have to stay? Just the one in the front, right? So what is my final answer here? The one I'm circling has to stay. Good. Perfection. Perfecto, just like that. Okay. Got a few more for us. You feeling good? Again, we're not doing the quadratic formula, okay? I decided let's take a day and just practice the part that I know you struggle with the most. And then when we go back and revisit assignment 17, you should find it to be quicker because you guys are still mooking around at like 14%. And so I think it's not happening early. Like you get how to use the formula. It's this stuff that's causing us to get that stupid box that says, sorry, your answer is not correct, right? It's usually not the first part. Here we go again. The square root is just 1. Good. Always watch like a hawk for this idea. It's going to happen to you several times on today's assignment. Watch for is it just on the red list? Can I forego all this nonsense about breaking it up into this times this? The square root of 1 is just 1. So I can just write the top like this. And this is now what is it? This is my pathway problem where I'm now literally going to trace 2 different pathways to get 2 distinctly different rational answers. So if I trace the pathway named plus, what is -6 plus 1? And what is -5 if you place it over 5? What does that equal? One of your answers is -1. Everything gets simplified. Always has since like 6th, 7th grade. The other pathway is called minus. What is -6 minus 1? And the other one, if I place it over 5, there's nothing doing there. So my other answer is just -7/5. Box those up. Okay. Next one. Do you remember, again, I'm not naive, like you've had 3 days off of seeing me, but last Thursday when we spoke, do you remember what we said happens when you get a 0 inside your square root? Say it again. It is just 0, so let's start with that. I was hoping maybe you'd kind of go bigger picture on me here, but let's start with specifically. You're right. That one fact is true. The square root of 0 is just straight up 0, so I can get rid of my square root sign. Now, the series of questions that I would ask you every time, if you ask me to teach this concept 100 times, I'll choose the same words all 100 times. What happens to 5 when you add 0? What happens to 5 when you add 0? Correct. Absolutely nothing. And yes, Aubrey, but I would like it if you just like answer the actual question that I'm on. But you're right. Okay. I didn't mean to ignore you, but I'm trying to get through a different point first. So when I add 0, I get the same thing, right? And I would ask you the same question again. What happens when I subtract 0? Nothing. So the point is, what happens is this. You should probably watch the TV here for a second. The plus minus 0 just goes away, and the answer just winds up being this. You see that everything else is pointless. Like, why put 5 plus 0 when it's just going to be 5? Why put 5 minus 0 when it's just going to be 5? So the only answer to this problem is 1/2. There are not multiple answers here. Remember that? Maybe. Okay, I got 2 more for you. Next one is positive 10 plus or minus the square root of 80 all over 6. So we know what to do. Grab the square root of 80, pull it off to the side, and rewrite it as a square root of something times something. And Aubrey's not allowed to answer this. Good job, Dalton. You found it. Sorry, Aubrey, I didn't mean to cut you off, but you just tend to get these really fast. So 16 and 5 is the magic combo. And I'm guessing that you're just using the daylights out of that times table, the factor thing. So if you don't have a copy of that, make sure you get your hands on one, because it lists out every way to multiply. And if the number is 100 or lower, then that's a gold mine of usefulness. So yeah, we definitely don't want to waste our time with anything other than 16 times 5. Right? Listen, there's a ton of ways to make 80, but they're all trash compared to 16 times 5. Even 4 times 20, trash, because the 20 would have to be reworked lower. Why just go big or go home? So when 16 breaks out of my square root prison, what does he become? He does become 4. So this is now 4 root 5. And that I will take and replace it where the square root of 80 used to be. And just like that, the Dorito is in play. Even without me drawing the silly green triangle, you get the idea. What can all the numbers in that triangle be divided by? 2. So let's divide them all by 2. And what they become is 5, 2, and 3. So my final answer, I'll write it in purple, is 5 plus or minus 2 roots of 5 all over 3. Last one. What are you talking about? Do you just have a little stroke? What are you doing? I'm just kidding you. What would what be 20? Nice job. So this is like the 4th time in this series of examples that I've hit you with this. I really want to make sure you do not go off looking for numbers that multiply to make 400, because 400 is on the red list. If it's on the red list, then I don't need a breakdown. I just need to know what it equals. And like Sergeant Speedy said over here, what is the square root of 400? It is right on my notes as 20. Perfect. It's right there. And you can square root a number. Oh, it's such a nice feeling. And now it is a pathway problem. And so the red pathway is plus. And as always, we just hope you have your basics down. What is negative 12 plus 20? 8. And so one of my answers is 8 over 20. Y tienes que dividir los dos números por 4. Tienes que dividir 8 y 20, los dos por 4. Tienen que reducir la fracción.
Why is it 20 when our bottom number was 4?
Yeah, I don't think it was ever 4.
Oh, okay, so
Yeah.
Thank you.
Yeah, yeah, we gotta reduce the fraction. You have to divide both numbers by 4, right? Look at my red fraction, right? Divide them both by 4, what do you get? Oh, that's if you divide them both by 2. 2/5 is what we're looking for. So one of our answers is 2/5. Okay, let's trace the other pathway here. And the other pathway is named minus. You reset, go back to the beginning. What is negative 12 minus 20? Negative 32. So if I write down negative 32 and I stick it over 20, what can you divide 32 and 20 both by? I agree. And what will you get if you do? 32 divided by 4, 20 divided by 4. Man, I wish you guys knew your times tables better. I've always said that for 20 years. It would be 8 over 5, right? 32 divided by 4 is 8, and 20 divided by 4 is 5, and it cannot go any further than that. And that is what you're doing today. Tomorrow in this class, we will be doing something else. It is the annual Thanksgiving word search. It's a word search that has 70 Thanksgiving terms that you get to find in the grid.
Nice.
So I would ask, please, that you maybe bring a highlighter to class tomorrow, or a couple highlighters, maybe 3 or 4, so you can find your words and highlight them. All right, then. I am ending the recording because I don't imagine you guys are going to have any more questions. So